afternoon. This is Dr. P. Chandana, working as an associate professor in the Department of CAIARE. So I am here with the subject of computer organization and architecture. So we have been given some introduction concepts in the last session. So now we are just giving the overview of the past sessions and I'll be going for the next case, that is CPU organization. So let's see the contents which were discussed in the past session. So we have started with introduction to computer organization, where we have covered with the basic concepts like introduction, followed by basic functional units, followed by basic operational concepts. And now we are going to have the same glance on that. And then we'll move on for the next case, that is CPU organization. So we have seen the basic concepts in the past cases. And now let's have a small introduction about the past one and we'll go on for the CPU organization. So what do you mean by a CPU organization? So we haven't seen in the last class, we have seen about the case of definition of a computer, where a computer has been learned as a peripheral device which accepts the input and process the task and presents you the results. Now, in order to consider this, or in order to perform or process the things, how it has been generally organized. So we already discussed the basics with the function of basic functional units which have been present in the computer. So we have seen the basic functional units in computer as a basic components like input, output, followed by memory unit, followed by control unit, followed by arithmetic logic unit. So we have said that these are the basic key components connected in the CPU. Now we have to see that if at all I am saying that these are the basic functional units, how these things are exactly collaborated with each other so that they can have the interaction with each other, so that it can give you the present the results as per the user's query. So now in this particular session, we are going to see about how the computer organization, the central processing unit, which you have been said as a central CPU, is being collaborated with the units like memory unit, arithmetic logic unit, control unit, and input output units. So in this session, we are going to see about the interaction of a CPU with all these units by means of interfaces, and we see what are the key components that are executed for this particular instructions. So let's start the session. So the combination which we have already discussed in the past cases, the general scenario of a CPU is it is combined with a set of input devices. It is connected with set of input devices and set of output devices. Now it is having a combination of internal units to process the tasks which have been combined together, and we define them as a combinations of control unit, memory unit, and arithmetic logic unit. Now that is one form of fabrication where the CPU is organized. And the second one is the same concept which is collaborated in different sessions, different formats, that input and output are common, which have been discussed in the previous slide. Now we are saying that how the central processing unit is being collaborated with each and every unit. We have two things. One thing is focused only especially on the memory, which is intended to handle the storage, and the rest all is the two basic things which you are handling with the control unit and arithmetic logic unit. We are keenly concentrating on these two units because these are the basic essential units which is intended to perform the task and intended to redirect the task. So control unit will be redirecting the tasks or controlling the tasks, whereas arithmetic logic unit is intended to perform the tasks. Is intended to perform the task. So now here, why we are integrating these two units as a special units, because these are the key portions of handling and processing the information along the CPU or in the CPU. So here the memory unit is intended exclusively for handling the storage information. We are not bothered about how it is stored and how it is organized and how it is being manipulated, but we are intended only for handling the storage. Now, we are saying that control unit is a unit which coordinates and controls all the units in the CPU. So, it simply accesses the information, or it simply presents you the signals to the corresponding units inside the CPU and connected to the CPU, either to direct the output or to present the output. So, these are the two things which have been considered by the control unit. Whereas, arithmetic logic unit is a case where you are performing data access, data processing, data operations, data manipulations, and simply giving the results to the end users. These are the things which are performed by the arithmetic logic unit. Because of these two reasons, because of these special reasons, the central processing unit is majorly focused on these two things than the memory unit. So in one way, memory unit is connected in the CPU, but in other format, we can say that memory unit is exclusively playing the role of storage access only. So now this is one form of fabrication of CPU, and this is another form of fabrication of CPU. That depends on the CPU fabrication which you are trying to explain is dependent on the designer purpose. So whoever the designer is interested, they can have their own explanation in a better way. For this reasons, we can handle two different approaches. One is a basic approach, which is the definitional purpose. Second one is the operational purpose. Now, in the past case, we have been seeing that data with respect to operations. So we have seen that data has been processed in memory. So we have simply said with the statements like, we have been taken an example stating that load R1 comma LOC, and we said that store, add followed by R2 comma R3 comma R1, and store R1 comma LOC comma R1. So we said that these are the three basic instructions which are followed in the last session. So we have been explained that how these things are exactly operated in the internal structure. So what are the instructions you are executing? First, this instructions is being saved and it is being loaded into main memory. Now, the memory is being executed, the memory is being called up for the instruction executions. So what happens now? Whatever the data is loaded in memory, this is called as complete data. This is called as complete data. Now, what is your intention? You have to execute that. So when you are trying to execute these instructions, this will not be fetched as a whole. It will be fetched line by line. So whenever the first line is called, it is loaded from main memory to instruction register. This is first step. So this is loaded from main memory to instruction register. Now, after getting the first instruction, it has to ready with the next instruction. That means the second instruction is again followed from memory to program counter. This is the second step. So memory is being executed. The memory is being fetched for the second instruction in the program and it is being executed in the program counter. That means the current instructions which you are running is loaded in instruction register. The next instruction which you have to execute, that should be loaded in the program counter. Why you are making this thing ready with the external components? Because we are getting the things ready in order to increase the speed of a processor as well as decrease the time limit to execute the execution or to execute the program. So in order to synchronize with the operations inside the program execution, we are making this to be in a faster manner in order to increase the speed of a processor. So these are the two things which have been mandatory for handling the operations. Now, the next instruction which we called up is executed in program counter. Now, what is the next instruction? It is addition of two numbers and storing the result into R1. Now, what you are doing? So, add instruction has been called. Now, who has to activate? Control unit has to activate the add signal. So, this is the second step. Now, basing on the second step, so first instruction is simply load. So, the simply load will be redirected from the control memory to main memory again. And LOC will be loaded with R1 or else simply R1 is loaded with LOC. Is the third case. So control unit will initiate the memory to store the data of LOC. So now it is being stored in the memory. Now how it is stored? It is not directly stored in the memory. By means of a registers it is stored. So it is getting the data from LOC and it is being fetched into R1. So this is a fourth step. Fetched into R1. So this is a fourth step. So using R1, we are storing the data from memory to R1. So why you are fetching the data again from memory to R1? Because LOC is stored in memory. This data is being fetched from LOC to R1. So what happened here? First instruction is called, it is stored in instruction register. And the next instruction is called and it is stored in program counter. When the first instruction is getting executed, It is initiated by control unit to fetch the data from LOC to R1. So R1 is loaded into, the LOC data is loaded into R1, which means that duplicate of this LOC is stored in R1. Now the next instruction is passed on to program counter. That means second instruction. The second instruction is add. Meanwhile, program counter will load the next instruction. That means store instruction. So the next step will be, so this is fourth step, this will be fifth step, this will be sixth step. The store program instruction will be loaded again into MAR. So loaded again into program counter. Loaded again into program counter. That is the sixth instruction. Sixth step in the execution. So once the program is been changed in the, once the line of the instruction has been changed in instruction register, now control unit will initiate the next target to complete. So next target here is addition of two numbers. So addition of two numbers means what? Again it is called up from R2 comma R3. R2 comma R3. So here we are using the registers to handle those operations. Here we don't know what is R2, we don't know what is R3, but it is being loaded from these registers and it is been initiated through the, it is initiated to, control unit is initiating these registers to redirect the task to ALU, and here these things have been called up to ALU. So this will be the seventh step. R2 and R3 will be loaded into ALU. R2 and R3 will be loaded into ALU. Now what is the resultant data is stored? So it is being stored in R1. Now what happens here? R2 plus R3 is getting loaded into R1. That means here, for example, R2 value is 10, R3 value is 20. This will be added with each other and this value will be loaded into R1. Now this R1 will be held where again? In R1. So this will be eighth step. This will be eighth step. Now what is the next initiation which was made? That is store LOC comma R1. Where is LOC? It is in memory. Where is R1? It is in registers. Now R1 is loaded with the new data, that is 30. R1 is loaded with the new data, so that is 30. So this is eighth step is initiating R1 value as 30. Now what happens? Now control unit will again initiate memory to redirect the data. So R1 will be again redirected to memory and this LOC will be changing its value to new value, that is R1. For example, this R1 is initially 10. Initially the R1 is 10. LOC value is 10. Now this will be changed with a new value of R1, that is 30. That is 30. So this will be my ninth step. So a simple 3 lines of code needs to take nearly 10 instructions or 10 operations to handle the task. So here the simple addition of two numbers and storing the vice versa operations requires 9 instructions to handle the execution. So how it is interacted, how it is operated, that will be initiated by means of a control unit, memory and arithmetic logic unit. So how it has to redirect, which has to operate first, which one has to redirect next, that is initiated again using control unit. So internally this is a overall collaboration of the units inside the processor. Now the impact of MAR and MDR plays a key role in identifying where to store the data in memory, which one to call up from the memory. For example, the first one is R1 comma LOC loading. That means data of LOC is loaded in R1. That means I am storing the data of LOC into R1. So here the data of LOC is ready with the data register and R1 is ready with the registers. So this will be redirected by means of MAR and MDR. So address location where the data is used in memory and address location of data in registers will be overlapped with each other. The data will be synchronized with each other. Next, as I am saying that the store value is storing in the data of R1 comma LOC comma R1. So now R1 has to be, the data which has been manipulated in R1 should be loaded into LOC now. So what I am doing again, I am fetching the data of LOC, the address of LOC in memory, and it is been overwritten with the content of R1. That is again, I am initiating the R1 to reload my content in memory. So here data is ready with the 30, MAR is ready with the location address. Now it is been written onto the LOC content. So in this way, the entire synchronization of data is happening inside the operation of a processor. So the impact of this MAR and MDR. can together be referred as process memory interface, processor memory interface, which has a combination of both MAR and MDR. These are the two things which has to be very keen about the data fetching from memory. The rest all are same. Only the thing is, how do you fetch the data from memory? Where do you place the data into the memory? So what data you have collected, what data you have to process, that should be impacted by means of MAR and MDR. So now let's go for the CPU organization. So this is the overall operational concept which have been explained. That means a single 3 lines code of execution requires nearly 9 operations to perform, the 9 types of control instructions to handle. Now we are concentrating the same operations and we are trying to synchronize that with a simple operation of how the CPU is performing all those things. So we call up this by means of a CPU basic organization. So here is the CPU basic organization, where you have already seen the control unit impact, control unit, arithmetic logic unit and registers. This section is being composed as control unit, arithmetic logic unit and registers. And the memory which has been focused, this can be called up as a memory unit. This can be called up as a memory unit. Input and output, as usual, we have seen with the technical definition, we have the same concept. Now, we have to discuss that when I am saying the data is operated from the memory to CPU, memory to control unit to ALU, ALU to registers, all these synchronizations. Let us see how these things are exactly operated. So, for understanding this, we have a simple definition. What is the objective of control unit? In order to handle the controls from among all the units, we are using control unit. Arithmetic logic unit is exclusively intended to perform the tasks. And third one is registers, which is used to hold the data locations for temporary purpose, or which is used to hold for a temporary data storage. So we are using these things, 3 things, and we are saying that how the CPU is organized with all these 3 things so that it can collaborate with all the other units in a proper manner. So let's start with the operation. So here we'll start with the basic operation, control unit, registers, and arithmetic logic unit. Now, what is initiation of control signals or control unit? It's intended to generate only control purpose or controlling operations. It will always process only control signals. So, it is the first step it has to coordinate. It will initiate the control signals towards the registers, initiates the control signals towards the ALU. This is the first step inside the CPU organization. Next, what is the operation of registers? Temporary storage. Temporary storage of data. Temporary storage of data. What is the operation of ALU? Process or perform the task. Okay. So these are the main objective of control unit. We have initiated the control signals to both the units. Next, data in the registers are used only for temporary storage. Now, the previous slide we said that there are n general purpose registers. Now, which register we have initiated? That is a major concern. In the previous case, we have seen that there are 3 registers used, that is R1, R2 and R3. Now, which register you are manipulating now? That is also major concern. Because of this reason, the registers have been generated with the 2 special lines, that is address bus and data bus. So, this is the second step. Now, the operations of ALU. What is the operation of ALU? Perform the task or process the task. For example, if it is C equals to A plus B, it need to access A and B first. First access A and B, process A and B, present result to the registers. So these are the 3 steps it has to perform. So we are writing C equals to A plus B. So simple statement requires 3 steps to perform. One is first, identify where A and B is there, process the information. Third one is result. So these are the 3 things you are performing. So because of this reason, and here C equals to A plus B may be from the memory or maybe from the registers. This is a simple instruction which can be called from the memory. But what about the instructions like for I is equals to 0, I less than 10, I plus plus, sum is equals to sum plus I. If this is a case, what happens? So in these cases, we have to understand that the sum will be initiated from 0 to 9. The sum will be incremented for n number of times, that is 10 times, and the operations will be initiated for sum to 0 to 9. That means every time for the first iteration it has to hold the data of sum. For the next iteration it has to add the data of sum. So in this way it has to increment so on up to the last value that has been reached, last iteration that has been reached. So in this purposes, we need to make use of the context called as registers. In this case, we may or may not use register. We can directly fetch it from memory. But in such cases of these things, we need to go for the context of registers. Now what happens here? Registers intended to hold the data for temporary locations. So ALU is performing the task. What you're doing? You're fetching data from the ALU. This is a third step. You're fetching data from the ALU and you're presenting results again back to registers. You're presenting the results again back to the registers. So these are the two things which you're performing from the ALU. Other than this, the ALU is not performing any task. So we are simply saying that data is fetched from registers, data is being written back to the registers. So here the data which you are processing or data which you are taking for the processing is called as operands. So data operands, data which you are assigning or getting the data, like A and B are the operands. A and B are the operands. Now the next one is results. So what is the result you are fetching back or presenting back? It is C in this case. It is sum in this particular case. So what are the data you are presenting? It is considered as a results. So these are the two cases which you are performing and returning back to the registers to ALU, ALU to registers. Now, as a part of control unit, we have initiated the data to register. We have initiated the data to be controlled to ALU, stating that you have to get the data from registers, process it, and present the result back to the registers. Now, in order to initiate this data, in order to initiate the control, we need to again have some sort of operations, that whether you are accepting data from register or sending back to register, it should be enabled with a signal. So we are calling again this with the data values with respect to control unit. Again, this will be stored in the form of registers in some cases, not every case. Something like I/O, memory read or write operations can also be considered as a signaling operations from the registers, which has to be held for a temporary location. Memory read or write or I/O operations, what are the operations you're initiating as a control signals, those will be considered as a data values. So these are the complete operations in the CPU organization. So what was the things we have learned in this particular session? The basic introduction about the computer once again, and we have stated the functional units impact. What are the major functional units we have concentrated? Next, we have already explained in the past session, but here again, in order to understand the internal operations of a CPU, we have been concentrated on the operational concepts. Followed by this, we have been learnt about how the CPU is connected with other components inside the processor and how the CPU organization with them or organization with respect to other processors are being executed, or with respect to other units are getting executed. So these are the things we have been learned for today's session. So these are the things which already explains you with the simple understanding that what is the definition of a computer, how the internal components are connected, how it is being organized so that it is being performing its operation. So we just have the overview of the session which has been continued for today. So we have to go for the same thing which have been already explained. So we have started with the computer organization with the CPU organization. So in this today's session, we have been just discussed about how the operations have been continued for the entire organization which is generally processed. So we are saying that data has been accessed from the input, it has been processed and it has been presented as an output. Now how this organization is generally having its impact. So we have just an overview of these things once again. So let's have the things how the CPU is organized, basing on the operational concepts. So these are the basic functional units which I have already discussed, and we said that it is a internal components which are connected in the CPU. So we are saying that the input-output unit is a basic combination for handling the I/O operations. Memory unit is for handling the storage, and arithmetic and logic unit followed by control unit are essential to handle the processing of operations and redirecting the operations within the CPU. So together we can call this as a central processing unit. This is one form of fabrication which I have already explained. The other one is this kind of general definition formatting. So again, input unit, output unit and CPU. This is one form of fabrication based on the designer execution. This is another form of a designer execution where you can see that a combination of control unit and logic unit has been combined together as a central processing unit, and it has been externally connected with the memory unit to handle with output and input devices. Now, when it comes to the context of a functional with operational concepts, we have already said that it has been generally composed of basic units like control unit, arithmetic logic unit and memory unit. Now, in order to hold for the data operations, in order to hold the data transactions inside the operations of a computer, we need to have a special form of things called as registers. We can also call this as a general purpose registers. Now, in order to synchronize the operations in the processing or operations in the program, we need to use a special form of register called as instruction register and program counter. And main memory is exclusively used for storing of information, storing the data. Now, it has been contacted and collaborated, or it has been communicated, collaborated with the means of a processor memory interface, which consists of two special memories called as memory address register and memory data register. Memory address register and memory data register. Now, this is a basic computer organization. The things which you have been seeing over here, like memory is connected with the control unit and arithmetic logic unit, or the combination of memory connected with ALU and control unit. So the things which you have been seeing over here as a fabrication can be explained using the communication links by means of a bus. So the communication links by means of a bus, because bus is a special communication line which is used to handle the interaction among all the units which are contained in the which have been communicated or which have been connected in the CPU. So this is a group of lines fabricated together to consider the interface between one unit to another unit. So these are the two these are the special interface communication lines used to exclusively connect the internal components of a CPU. So CPU with a control unit, memory unit, followed by arithmetic logic unit, followed by I/O. All these things are communicated by means of a bus. So the types of bus, we have this combination is called as bus. There are three types of buses which have to concentrate. The first thing is address bus, data bus and control bus. One to initiate the location, one to initiate the transfer of data, one to initiate the operation of data. So these are the three types of operations which have to perform. So the first thing which have connecting over here is connected with the CPU, memory and I/O. So why you are calling this with the memory subsystem? Because memory is having both RAM and ROM, or else we can say primary memory followed by secondary memory. Primary memory and secondary memory. So because it is a combination of so many types of RAMs inside, we are calling this as a memory subsystem. Memory subsystem. Now, when it comes to I/O device, there are n number of devices connected with the I/O, or n number of devices connected with the CPU. For example, for a simple laptop, we may connect a keyboard, we may either connect a mouse, we may either connect a pen, or we may either connect any other device. So, there are n number of input devices and output devices can be connected with a simple laptop or simple desktop. So, the other form of outputs we can have is, we can have a combinations of TVs, we can have a combinations of monitors, we can have a combinations of display devices like projectors and all. So, because we are connecting a number of output devices to the system. We can say this as a basic output devices, basic input devices connected with the iBio system. As we are connecting n number of components of iBio devices, we call this combination as a iBio subsystem. So iBio subsystem is a case where you are connecting n components or n multiple iBio devices as a whole. We are calling this as an iBio subsystem. And the combination of this is being connected with the combination of iBio interface. iBio interface. So in this way, we are concentrating on the iBio followed by memory and CPU. So we are saying that how these three things have been connected with each other. So first, it has to, any kind of unit which is internally connected, it has to communicate by means of address bus, data bus and control bus. Address bus is to initiate the address of the location from where it has to fetch or where it has to redirect. Data bus is a communication link which allows to handle or to simply transfer our data onto the corresponding location. Control bus is to initiate the signal to the corresponding devices. For example, I am performing memory read. So I have to initiate the signal to memory. And I have to perform write. So I have to initiate with the signal. So read or write signals have been initiated by means of a control bus. If it is related with iBio, then it has been connected with the iBio read or iBio write. So in this way, it has been connected with the communication links by using a bus combination. So the overall system components we have in general are CPU, also called as microprocessor, memory subsystem and iBio subsystem. Now the things in the computer have been generally handled by means of a concept called as clock cycles. Generally, a programs or task or any operations in the CPU is performed by means of a clock cycle. So the clock cycles over here will be generating the task to execute. It doesn't matter whether you are starting it now or any other time. As it is a digital mission, it has to execute by means of timing pulses only. And the representation of these things should be considered by means of an instruction cycle. So in general, the instruction cycle is consisting of 3 phases. Now what do you mean by instruction cycle? So we can say with the example by means of a case. For example, I am writing add of R1 comma R2 or R1 comma R2 comma R3. So what does this instruction mean? It is meaning that R1 implies R2 plus R3. So that means data in R2, data in R3 is added and it has been stored into R1. So these things are being generally understood by the human understanding. But internally, missions are being generally concentrated or executed in the form of ones and zeros. So it cannot understand easily. So how to execute this or how to execute or how to manipulate this? For understanding this, we need to go for a context called as instruction cycle. The instruction cycle has 3 phases. First one is fetch. Second one is decode. Third one is execute. First one is fetch, second one is decode, third one is execute. So fetch phase represents that what is the instruction. So I have fetched the instruction. So the instruction name is add R1 comma R2 comma R3. Now what is the second one? Decode. Decode means what does that instruction mean? So first one is what is instruction. Second one is meaning of the instruction. Meaning of the instruction. Here we are writing add of R1 comma R2 comma R3. Add means it is simply arithmetic operation. It is simply arithmetic operation. So the arithmetic operation which you are focusing here should append 2 numbers or to add 2 numbers and store the result in somewhere. The result somewhere is nothing but registers. Registers. Now, what is the task? It has to perform arithmetic addition. So we have just fetched the meaning of the corresponding instruction. Now we have to execute. So perform the task. So first one is what is the instruction. Second one is understand the meaning of the instruction. Third one is perform the task of the corresponding instruction. So first one is we have fetched the instruction, that is add instruction. Fetch the instruction, that is add the instruction or add instruction R1, R2, R3. So this is loaded. R1, R2, R3. This is loaded. Next one is understand the meaning. So what is the operation intended? Add. Addition of two numbers. Now, third one is execution. So what it has to perform? Execution. So execute. Execute add or execute addition of two numbers. So this is performed in ALU. So in this way, the instruction cycle has been performing its operation in three phases. First one is fetch, second one is decode, third one is execute. So here why we are concentrating this is, as we are saying that every instruction in the CPU is operated by means of a timing pulses. We are generating clock cycles to execute. And here we are performing the task of read, and write. So we are performing task of read and write. Read means there is one location, say address as 1024. Now I have to get the data from that particular address location. For example, the data is high. The address is 1024. Now I have to read the data from address 1024. Now what I have to do? I know the address first. The first step is know the address. If I know the address, then only I can handle the data. That means I can get the data from that particular location. So once I know the address, what I have to do? I have to go there, get the data. That means in the first cycle, it is started with the address knowing. Then it starts with the appending of data followed by generating the signal. So first step, in the first cycle, it will execute the address presentation. So know that know the address first. In the second cycle, it will initiate the data. That means transfer of data from that location by initiating read signal. So these two operations are performed in the second clock cycle. So we can see this. The clock cycles are generally digital pulses and it has been executed in the digital notation. In the first line of clock cycle 1, we are generating the address. In the second line of in the second clock cycle, we are initiating the data transfer followed by the read signal. So these are the two basic things which are performed in the clock cycle 2. When it comes to write operation, so what you have to do, the same, let us consider the same combination. So in the first case, I went to the address, I fetched the data and I came back by issuing a read signal. Now the next one is write signal. That means there is one location, say X. In the text, I need to put the value A equals to 10 or I need to put the value hello. Now what happens here? Address is mandatory, data is mandatory and I need to issue the signal. So I have the address, I have the data, now I have to issue the write signal. So I have to know the address before, I have to get the data before and then I have to initiate the signal. Because of this reason, in clock cycle 1 itself, address and data gets initiated. But in the second clock cycle, it will initiate the write signal. It will initiate the write operation. So in this way, we are concentrating on the instruction execution inside the CPU. Now, the components inside the CPU is calibrated in such a way that it will have the better interaction with other units so that it can collaborate and coordinate with each other. So here, we are saying again with the same example of the general case of a LOC, R1, 3 instructions execution by means of operational concepts. And we see that how it has been executed by means of a line by line operation. So for a simple 3 lines of instruction, it requires nearly 10 operations or 10 micro instructions to get executed. Now, we have been seeing that how the collaboration between ALU and CU can be interacted with each other by means of registers. So we have a combination of these things by means of a simple statements by issuing a signal called as control signal followed by data signals from to and fro from control unit to ALU. ALU to registers and registers to control unit. So control unit intention is to simply issue the signal. What kind of signal it has to issue? It is dependent on the instruction. For example, I am writing store. For example, I am writing C equals to 10. That means 10 is being loaded onto C. That means I am writing the data. If at all I am saying that A equals to read A comma B. That means it is getting data from the input source. So A is being called up from the random location, B is called up from the random location. That is write operation. So what kind of issue which is making? Is it from memory or is it from IO or is it from any other registers? That is initiated by means of a data values. So these values have been generated by means of these signaling operations are generated by means of control signals and data value representations. Whereas ALU is an operation which performs exclusively task executions. What kind of task? It is dependent purely on the arithmetic and logic operations along with shift operations. So all these operations have been generally operated in ALU. Now ALU has been focused combination with respect to registers. Now we are saying that temporary locations of data for manipulating the simplification or for manipulating the executions are managed in registers. Now when it is managed in registers, how these registers are, how many registers are there, how many registers we have been used, how many registers it has to operate, all these things has to need to have some unique identification. For this, address bus and data bus are mandatory. Now the registers will be generating its data for a temporary purpose or storing its data in a temporary operations, and it will be fetched to ALU and redirected from ALU. For temporary executions, it will be maintained in the form of registers. So all these things are collaborated with each other so that our execution of a program within a simple instructions can be well defined and well executed in the entire execution of processor. As a simple statements, the basic combinations which I have learned for today's session is the general introduction about computer, followed by functional units, what are the major function units we have, followed by instruction executions, how it is exactly performed by means of by taking an instructions. We haven't seen how the operations in the instructions have been generated. Now the next one is how the functional units inside the CPU are executed. How the functional units are connected and collaborated. Next one is how the different units have been connected by means of signaling operations, by means of buses, instruction cycle, and other tasks operations. Instruction cycle as well as using control signals. How each and every units have been connected with each other. So all these things have been explained for today's session. So we'll see with the next task by using memory interleaving, and we see in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.